So today we're working on a haunted house. This one's had all its ground mods done and all that kind of happy stuff. But what it is having a problem is when the ball goes to the lower playfield, which I now have vertical, well I have the upper playfield vertical too, it ends up in this kicker. And what happens is it closes this switch right here, which tells the computer that there's a ball in there. It plays the assorted noise, and then this relay here pulls in, closing this switch, which kicks the ball up vertically. The problem with this, now you're going to ask, why did they do that? Why did they use this relay? Why didn't they use like a driver transistor opposed to a relay? They could have mounted an under playfield transistor. They could have gone that route, but for some reason they didn't. Maybe they didn't. I'm not really thinking why they would do that. I mean, look, there's one right here. This is how they get around that kind of stuff, is that they can use a lamp driver transistor to pre-drive one of these big monsters that then drives, an associated coil. But for whatever reason, they didn't do it like that. They use this relay. And the problem is that if this switch contact isn't adjusted nicely, kind of isn't here, or these get tarnished, which is really, really common, and that's why there's a capacitor on this switch, is to try and prevent some of the arc across this, to prevent the contacts from getting burned. You get inconsistent usage of this. So what I'm going to do is I'm going to basically replace this relay with a pop bumper driver board. Now this is a standard pop bumper driver board used on all these games, on all system80 games. And I've done some general modifications, the standard modifications, which have been well documented, and plus I add an LED for plus 5 volts and an LED for the 28 volts, which is the coil voltage. But other than that, it's just a standard pop bumper driver board. Now one thing I should note is that there is no 5 volts on the mini playfield, and 5 volts is needed to run that little board. So the big trick is, how do you get 5 volts to this board? Now it's interesting, there's a pop bumper here, but there's no pop bumper driver board down here. Instead, that pop bumper driver board's on the main playfield. And I think they did that because they didn't want to run 5 volts. I'm not even really sure why they did that. You would think that the pop bumper driver board, there's plenty of room, they could have been right here to control this, but there wasn't. If there was, then it would be real easy. We'd have 5 volts on this mini playfield. But we don't have 5 volts, so we're going to get 5 to the mini playfield with a little wiring that we're going to have to add. Why do I want to use a pop bumper driver board to control the vertical up kicker? This provides a consistent pulse to the coil, meaning that your vertical up kicking will be pretty much the same every time. If you notice, like on Williams pinballs, they really don't use relays for anything, where Gottlieb, even in the electronic era, still used relays. They had a hard time getting away from their electromechanical roots. That this is the way to go. The vertical up kicker on the haunted house has been problematic, largely because those switch contacts like to burn. So another problem with this design, this is the vertical up kicker, is you'll notice that they've used, on this particular game, a brass sleeve, and how it's been peened over around the edge. This makes it nearly impossible to get this coil out, but what it does do is prevents a problem that's pretty common on this. That is, when the ball comes down and rests on this, if you have a nylon sleeve, it breaks the nylon sleeve, eventually cracking it, either making it so the plunger won't come up or making this coil come out of this upper bracket and become loose. In either case, you get ineffective vertical up kicking. So what someone did here was a nice idea with the peened over brass, but I want to replace this coil, and unfortunately I can't. I also would like to add a spring here, and again, I really can't because I can't get the damn thing apart. But that's just another one of the reasons why this whole setup never really worked as well as it should have. On the pop bumper driver board, other than modding it with the 2 LEDs, and of course doing the standard upgrades, like taking the diode out where this jumper is and reversing this cap and always replacing this cap, on the back side you've got to add a capacitor between pins 4 and 5. This is a 4.7 microfarad electrolytic capacitor, And you see on pin 4 I have the negative lead here, and pin 5, which is 5 volts, I have the positive lead of the cap. And the reason that you need this cap, and excuse these resistors, those resistors are actually for the LEDs, so don't get all freaked out about that. The reason why you need this is to decrease signal noise. Because of the long length of the lines going to this thing, sometimes you can get signal noise and it'll misfire or just fire the upkicker for no apparent reason. So that capacitor, that added cap, kind of takes that out of the equation. I have my little pop bumper driver board mounted right there. Now I just have to wire it up. I think first I'm going to work on getting the 5 volts to it. So again, I'm going to just run wires down through the harness and back to and pick up 5 volts off the main playfield on one of the pop bumper driver boards that are there. That should be fairly benign and easy, and I won't need too much wire to do it. Between the two playfields there's these 3 connectors that go to the mini playfield. Every wire is used on these connectors except for one. There is one empty spot right here by my thumb, and this is on A9P2 or A9J2, depending on which side you're looking at on the plug. But we have a wire here. I'm going to run 5 volts using a 0.093 inch round female and male pin, and then I can run it up through this harness into here and pick up my 5 volts on one of these 3 pop bumper driver boards, which are already on the bottom of the playfield. So that'll be an easy way to get my 5 volts. So I crimped on a male pin and used this red wire, which is so unlike Gottlieb. Actually what Gottlieb did is they bought white wire, and then they had their own wire color striper, and they would stripe their wires. That's why they always, basically everything's always white or green. Anyways, on our little connector here on our pop bumper driver board, I got to get plus 5 volts. Now plus 5 volts is pin 5 on this 6-pin connector. So it goes 1, 2, key, 3, which 3 is the key, 4, 5, 5 is the 5 volts, and then ground. So 5 volts is this wire right here, which is, let's see, what is it? It's white, obviously is the base color, and then it's gray, blue. So it's this one right here. So what I'm going to do is this is kind of a weird connector, but I can actually peel the pin out and put a crimped one in and crimp the original wire along with my red wire into a single pin in a nice clean look, and make it look good without having to do some monkeying around. So what we're doing is, this is an IDC housing that we are going to reuse with a single crimp pin with my new 5 volt wire attached on there. What I've done is I've crimped my pin into the 2 wires, the original plus 5 volt wire, which is the white wire, and my new red wire into a single pin. No, this is not a trifurcon pin. And then on the connector housing here, I know it's going to be hard to see, but what you do is you take a flat blade screwdriver and you push down on the little locking pin to unlock it. I mean, you permanently push it in, and then you can pull the pin right out. And the pin comes out pretty cleanly. Here it is extracted. It comes out, and then after you've got that done, you can slide this new one right into the original IDC housing. So I have the pin inserted in there, just slid right in there, and we're good to go. Just plug this right back in to my pop bumper driver board, and now my red wire is my plus 5 going to the male side, and now I just have to put in a female pin right on this one empty spot with my wire and bring it back to the underside of the mini playfield. So now I have my red wire run through the harness and back to one of the square connectors there where I put the female pin, and I've wired it into pin 5. Now this is really the hard part of this whole thing. The rest of it's fairly benign and easy. You're just going to be transferring wires from components here and on the coil over to the pop bumper driver board. You're basically going to be rewiring this whole section. So let's start wiring that guy. First thing we got to do is take this wire and this wire, take them off this switch, and tie them together. Now the reason for that is this is power, and what this relay coil does is it basically completes the path of power to the coil, opposed to grounding the coil. Most coils, the way they work with transistors is the ground is controlled, but in this situation they're controlling the power to the coil. And you can see here's the hot, the 30 volts goes through this switch, which is normally open. When the relay pulls in, the switch closes, goes through a fuse, goes over to the coil, banded side. So we're going to tie this wire and this wire together so this switch no longer does anything. Alright, so I took the wire off the relay coil, the non-banded side, because the banded side is power. I don't want this. I want the non-banded, which is the computer control wire. And then you run it over to pin 4 of the pop bumper driver board. So I just crimp a new 0.156 trifurcon pin on there and plug it right in. What this wire is the trigger. So when the CPU grounds this wire, it tells the pop bumper driver board to fire this guy. Next step, you notice these green wires on the non-banded lug of the coil, non-banded diode lug of the coil. These are grounds, and remember, because this guy just basically completed the path to power to the coil, these went directly to ground. We can no longer do that because the pop bumper driver board is going to control the ground. So we're going to take these two off, keep them tied together, and then run them over to here to pins 2 and 6 on the pop bumper driver board. So we're going to disconnect this, extend the wire, 2 pins over here. So 2 green wires tied together to pin 2 and 6 over here. So now we add our last wire, the purple wire right here, which goes to the non-banded side, the ground side of the coil, and that goes over here to pin 1 of the pop bumper driver board. So when the pop bumper driver board fires, it grounds this line, which grounds this coil, which fires the upkicker. In the middle of a game, have my pop bumper driver board powered up with the +5 LED on and the coil voltage on. And I'm going to manually close this switch, and you can see it now fires that coil when I do that. I wish I had this spring in there. Gravity pulls this thing down. Can't get my big, there we go. So I'll do it again, hit the switch one more time, and you see it fires it up. So now it's not using this relay at all anymore. That's completely out of the system. It is now using the pop bumper driver board. And I can just do that. So let me lower the playfield. Okay, got the playfields down. I'll just stick the ball in here. Kicks it out nice. And it's consistent because it's an electronic thing opposed to that goofy relay. So we get nice controls. Works really well.
Got rid of the fuzz for you.
And there we have it. There we got our haunted house with the modified upkicker using a pop bumper driver board.